So number one, what is the physics definition for energy? So the definition your book gives you is energy is the ability to do work. But I like to say it's basically a property of an object to do things. What I mean by that is energy is what an object has so that it can do things. Well, what things? Move, do work on other objects, that sort of stuff. Energy is what an object has if it's going to do anything. An object with no energy cannot do anything. An object that has energy can do stuff. The unit BizWiz is joules, same as we've been doing. Mechanical energy is just a fancy word for a physical energy. Okay? We're going to only be doing mechanical energy. So if you see a problem that says mechanical energy, I mean energy. Okay? We're not going to do any other types. But there are other types. Electrical energy, chemical energy, nuclear energy. There are other types of energy. We're just not going to do them. Okay? We're just going to stick with mechanical energy here. All right. Number 3. What is potential energy? So I want you guys to do 3 and 4. Think about the lab. What is potential energy? And then the specific type of potential you've used is gravitational potential energy. So think about what potential energy is. Think about the specific type you did from the lab. You don't need to do the equation, although you can get it from the lab easy enough. And then the height above, we'll talk about that as well. But think about potential energy and some examples. And then number 4 as well. I'll give you some time to answer. All right, Aaron, what do you think potential energy is? All right, let's look at the lab. So the blue bar here is potential energy. What do you think potential energy is just based off of what the skater's doing? That's a good start. Yeah, that's a good start. Vincent, what do you think? Potential energy. So it does have to do with work. What can you tell me, Vincent? Good. So it has to do with height. Okay. How high you get. Good. What else can we say? Benjamin?
Like the potential for the energy when the object is going to move.
Yes. So potential energy is stored energy. Okay. Where does it come from? It comes from work. So Aaron's exactly right. It comes from the work an object does. How is it related? Vincent's exactly right. It has to do with the height. Okay? But as far as a definition for potential, it is stored energy. All right, so what are some examples of these? I'm going to give you some non-mechanical examples. So one type of potential energy is gravitational potential energy. That's going to be down here. But some other examples of these would be like batteries. So those are electrical energy, stored energy. Okay, another good example would be dynamite. That's chemical stored energy. Okay, another good example is nuclear bombs. That's nuclear stored energy. So there are lots of different types, but the one we're going to look at is gravitational potential energy. So this is stored energy due to height. And the equation is this, PE equals mgh. Now the question is, the height above what? Well, we would normally think it's the height above the ground, but it doesn't actually have to be. So if you look at your skater, it doesn't have to be the height above the ground. It is the height above the ground here, but I want you to see something. Notice that nothing actually changes about the person's motion if I change it to be the height above the starting point, or I change it to be the height above the middle point. It changes my values, sure, but it doesn't actually change what's happening to the person. So what we're going to say for height above what? We're going to say the height above 0. So where is 0? It's wherever you want it to be. Do you want to make it the ground? Great, make it the ground. You want to call 0 the sky? That's fine. You want to say 0 is where you start? That's fine. 0 is where you end? All of it's fine. It's the height above 0, and you decide what 0 is, which we'll get into more later. We're not going to do that so much today. But we'll get into that a little bit later. Height above 0. Okay, what does gravitational potential energy always equal? It always equals the work done to get to the current height. Number 6. There we go. All right. Figure 7.6 on page 114 shows the gravitational potential energy of a boulder 3 meters above the ground is the same no matter how the boulder got to that position. Explain why this is true. Okay. There are 3 ways to get 3 meters above the ground for this example. I can lift it and put it on top of a table that's 3 meters high. I can push it up a ramp to a top of a table that's 3 meters high. Or I can push it up some stairs 3 meters high. We said that potential energy comes from the work done to get it there. Which one of these does the most work? No, they all do the same. Work is forced over a distance. What's the distance? 3 meters up. The forward distance doesn't matter because we're working against gravity. Gravity's up and down. So the vertical height is what matters, not the forward height. So it doesn't matter whether I push up a 5-meter ramp or a 30-meter ramp. If it goes 3 meters above the ground, it's the same work. Okay? 3 meters above the ground, same amount of work. So no matter what you do, it's the same. And the reason why? So 3 meters, no matter how you get to that position, we said it's the same. Why is it? Because it's the same work to get there. Remember, work is equal to force times distance. You have to apply the same force, whether you lift it, push it, slide, same amount of work. Now, it may be easier to do it some ways. A ramp will be easier, but that's because of power, not because of work. When you push it up a ramp, it takes longer, so the power is lower. Okay, work is equal to force times distance. So it's the same. All right, would an apple 1 meter above the ground on the Earth and on the Moon have different potential energies? Why? How can an object have 2 different potential energies at the same time? Think about the equation for both of these. And then number 9, what is kinetic energy? I want you guys to do these right here on your own now. 7 through 9, I'll give you some time.